Good morning, guys. We're going to be marking this. This is what I'm given here. Some of you have actually split x and 3. Please note, obviously, if we've got a base of 2 here, we've got a base of 2 over there, and there's minus in between. Therefore, we have to make sure that these bases, the exponents, are not added or subtracted. So we're going to try by all means to split the exponents. But when I say split the exponents, you only split them where there is addition and subtraction. Just like when you have addition and subtraction between the bases, you just know how you have to split the exponents. But when you split the exponents, you can't split 3 and x. You just split 3x and 1 because those are two different terms. Okay, you're going to take 3x and give it its own, take 3x and give it its own base, which is 2. You're doing nothing wrong here because 3x and 1, they share the same base, which is 2. All you're doing is you're just giving those exponents their bases differently. You just split the base and just give each exponent its own base, which is still 2. So I'm going to take this one and give it its own base, which is 2. I have minus, so I'll still keep the minus between the bases, and then I have 2 to the exponent of 3x. I'm going to take the 3x, obviously, it has its own base, but it's not added with anything, so it will still be 2 to the exponent of 3x. In the denominator, I have 4 multiplied by 2. This 4 doesn't have the 3x. In all of this, guys, you need to know that I'm trying by all means to make sure that I have similar terms that I can actually cancel out as common factors. All right, I know that in my numerator I have 2 to the exponent of 3x, and I also have 2 to the exponent of 3x. That will be my common factor. So in the denominator, I'm going to try by all means and try to make sure that I have 2 to the exponent of 3x. So I'm going to split this base of 2 actually and give 3x its own base, and this 3x will have a base of 2, and the 1 will also have a base of 2. Hence, I will have 2 to the exponent of 3x times 2 to the exponent of 1 minus 2 to the exponent of 3x. In the denominator, I still have the 4. However, I'll split that exponent. I gave 3x its own base, which is 2. So I have 2 to the exponent of 3x times 2 to the exponent of minus 1. In the numerator, you will realize that you have a common factor. We have 2 terms, so you're going to take out that common factor, which is just 2 to the exponent of 3x. Some of you might be tempted to take out a common factor in the denominator. Please know that you can't take out a common factor in the denominator. You can only take out a common factor if there is addition or subtraction. In the denominator, we just have factors that are multiplied. All I'm going to do is just to take this factor and put it as the first factor. That's all I'm going to do. I'm not taking out a common factor. However, in the numerator, if I take out that as a common factor, I'll be left with 2. If I take out this as a common factor, I will be left with 1. Please note, the first term I'm left with 2 since I took 2 to the power of 3x as a common factor, and over there I still have the minus. Here is the minus. There it is over there. I still kept it as it is, but where there was 2 to the power of 3x, I'm left with 1. In the denominator, however, all I did was just to put that 2 to the exponent of x as a first factor. I've done nothing. I didn't take out any common factor. I still have 4 times 2 to the exponent of negative 1. I've made no differences at all. Now that I've taken out a common factor, I can simply say 2 to the exponent of 3x goes into 2 to the exponent of 3x once. Because they share the same base and the same exponent, you just cross them out. I'll be left with 2 minus 1, and 2 minus 1 in the numerator will be 1. In the denominator, I'll be left with 4 times 2 to the exponent of negative 1, which is the same as 4 times 4 times a half, which is 4 divided by 2. All I did was just to take this base of 2 to the denominator. It goes with its own exponent, which is -1. Remember, I said to you here, you simplify without using a calculator. So please make sure you don't use a calculator. In the numerator, I still have 1, but in the denominator, I have 4 divided by 2. 4 divided by 2 is just 2, and that will be my final answer. Let's go to the next one. I have 2 to the exponent of x plus. Immediately when you see plus, you know that if your exponents are added or subtracted, you need to split them. So I'm going to split this 2 to the exponent of x plus 1 by giving x its own base of 2 and 1 its own base of 2. In the numerator, I will have 2 to the exponent of x plus, I still have the plus, 2 to the exponent of x multiplied by 2 to the exponent of 1. We normally never write that one. Now, in the numerator, take out your common factor. Which is 2 to the exponent of x. If there was 2 to the exponent of x, I'll be left with 1. In the first term, I still have the plus. Where there was 2 to the exponent of x, I'm left with 1, even though I don't write it. But it's multiplied with that 2 to the exponent of 1. 1 times 2 to the exponent of 1 will simply give me just 2. So basically it's just 1 plus 2, which is 3. 2 exponent x and 2 exponent x, you cross them out, you will be left with 3 in the numerator divided by 1, which is just 3. Let us do another extra example. In the numerator, we have a minus between the bases. We also have a minus between the bases in the denominator. So split your exponents if there is addition or subtraction between them. I am going to give x a base of 2, and I will give you minus 2. I'll give minus 2 a base of 2. In the denominator, I'm going to take this x and give it a base of 2. And take the 1, give it the base of 2. This is what I will have. In the numerator, I do have a common factor of 2 to the exponent of x. In the denominator, I also have a common factor of 2 to the exponent of x. Remember, you only take out a common factor if between the bases you have plus or minus. In the numerator, where there's 2 to the exponent of x, I'll be left with 1. So if I take it out, obviously I'll be left with 1. And in the second term, I'll be left with 2 to the exponent of -2. I still have the minus in between. Nothing has changed. In the denominator, I took out this as a common factor. So in the first term, I'll be left with 2. In the second term, I'll just be left with minus is still 2 to the exponent of x crosses out with 2 to the exponent of x. In the numerator, I'll just be left with 1 minus 2 to the exponent of minus 2, and that will give you 2. While it will give you 1 minus 2 to the exponent of minus 2, in the denominator, I'll just be left with 1. That is 2 minus 1 is just 1. In the numerator, when you simplify that, this is what I simply did. It's the same as though you have 1 minus 1 over 2 to the exponent of 2. Okay, so I've just divided each of those by 1. Remember here, if the exponent of a base is negative, you take that base and its exponent to the denominator, and then in the numerator you'll be left with 1. We did go through that. So you'll have 1 minus 1 over 4, and that will give you 3 over 4. Another example. There is minus, so basically your bases are added. In this case, they are subtracted. So you need to split the exponents. X, give it its own base of 5. Give 2 its own base of 5. In the denominator, give x its own base of 5 and negative 1 its own base of 5. In the numerator, you will have 5 to the exponent of x times 5 to the exponent of 2 minus 5 to the exponent of x. In the denominator, you'll have 5 to the exponent of x minus 5 to the exponent of x. You can write it as times 5 to the exponent of minus 1. I just jumped that stage because if the base has a negative exponent, you just take that base and the exponent to the denominator. That's all you do. That's why I have this 5 to the exponent of x divided by 5. But you could have just written it like this. Just like I did in the previous example. If you know your exponential laws, this should actually be very, very simple for you. Because all I'm doing when I split the exponents, I'm simply reversing the initial exponential law that was applied. For example, 5 to the power of x multiplied by 5 to the power of 2. You normally write it as a base of 5 and you add the exponents. But now I'm just reversing that law. If the exponents are added, it means that the bases were multiplied. So I had 5 to the exponent of x times 5 to the exponent of 2 before I got that 5 to the exponent of x plus 2. But I don't want to confuse you with that, okay? I've written a little note here for you just to show you, just to explain what I've been doing. Alrighty. In the numerator, take out 5 to the exponent of x as a common factor. In the denominator, do the same thing. I'm just showing you that if you did it the way I showed you earlier on, instead of putting that 5 in the denominator, you could have written as 5 to the exponent of x times 5 to the exponent of minus 1. So if you take out 5 to the exponent of x in the denominator, you'll be left with 1 minus 5 to the exponent of minus 1. I hope that makes sense. Okay. In the numerator, I'm going to take 5 to the exponent of x as a common factor. Take it out. I'll be left with 5 to the exponent of 2 minus 1. In the denominator, if I take this 5 to the exponent of x out as a common factor, I'll be left with 1. If I take out that 5 to the exponent of x as a common factor, I'll be left with 1 over 5, 1 over 5 that is. Now, 5 to the exponent of x and 5 to the exponent of x. In the numerator, you will have 25 minus 1, and 25 minus 1 is simply 24. In the denominator, for you to add 1 to subtract 1, well, to subtract 1 over 5 from 1, you had to find your LCD. Now remember, for you to find your LCD, this one will be multiplied by 5 over 5. We did fractions earlier on, and I'll have minus 1 over 5. If the denominators are the same, in the numerator we'll be left with 5 minus 1. That is how we got that. I simply applied my LCD in the denominator. In the numerator, I still have 24. It is divided by 4 over 5. So all I did was just to change this line and make it a division sign. Change that division sign to multiplication. You'll have 24 multiplied by 5 over 4, and that will give you 30. This is your classwork. Here is another classwork.